Hi students, welcome to Max Point of View. Today we are going to understand the concept of refraction through a lens, the two part A, lens and refraction through a lens. So many students will skip this chapter because this chapter is mainly of important terms, that is nothing but the definition. As you know, in the board exam definitions will not be that much, that's why students will try to skip this chapter. That is correct, but along with that many logical and give reason type of questions will be asked from this chapter only. So if you find any logical question in the board exam or any other papers related to refractive index, when lens kept in a water instead of air, all those kind of logical questions and give reason type of questions are asked from this chapter only. So without wasting any time, we'll start with our concept. Now we will learn everything about the lenses. See, as I told you, this chapter part A of refraction through lens is more than the definition. It has many things apart from the definitions. So we'll learn one by one. So what is the definition of lens? What actually is lens? Okay, a lens is a transparent refracting medium which is bounded by either two spherical surfaces or one spherical surface, one plane surface. So this is how you need to understand. See, lens is a transparent refracting medium. It is transparent. It is used to refract the light, correct? So lens is a transparent refractive medium bounded by either two spherical surface. See, this is one spherical surface and this is one curve, correct? Wherever we see curve, that we considered as spherical surface, or one spherical surface, one plane surface. Okay, this is the definition of lens. So whenever we talking about lens, there is one note point they have given. If you are considering this plane surface as spherical surface, sometimes we can consider like that also, just for an assumption. If you assume like that, then the radius of curvature, what we are going to learn in the next slide, okay, that will be infinite. Okay, see, whenever you assume this is a spherical surface, correct, because it has curve, but this is a straight plane surface. So this plane surface, if you assume it as spherical surface, if you assume it as one more spherical surface, okay, then its radius of curvature will be infinite. Keep this in mind. Okay, MCQ or somewhere it might be useful, because all the note points and just before the page numbers, okay, whatever the points they have given, those are very much important. Okay, now definition of lens is done. Now we'll talk about lens, types of lenses. One, convex lens, then concave lens. Convex lens and concave lens. See, convex lens are also called as converging lens. They are also called as converging lens. Concave lens are considered as diverging lens. Okay, so here convex lens, why it is called as converging, what do you mean by converging, all those things we are going to understand. Listen, convex lens, these are the convex lenses, but in the convex lens only there are three different types. Okay, these are concave lens. Okay, in concave there are three types. What do you mean by converging? See, whenever you give a ray of light, okay, a ray of light, okay, it comes back, okay, it will try to converge. Converge means moving towards other end. See, this is one end and this is the other end, correct? So why do we call it as converging? Converging means if you give it at one end, this top, it will try to come towards this top, okay, this bottom, like not exactly here, towards, okay, towards, okay, it crosses the center, assume there is a center line. So what is the name of that center line, all those things we are going to learn, don't worry. Assume there is a center line. If you give a light right here, it will crosses. If you give a light here, again it crosses like this. So this is called as converging. Okay, converging means okay, intersecting at one point. Okay, this is the meaning of converging. Next, concave lenses are called diverging lenses. Diverging lenses, that means if you give a light ray here, somewhere here, instead of coming, okay, towards the midpoint, it goes away. So this is the meaning of converging and diverging. That's it. Don't worry much about converging and diverging. If you know this much, that is enough. See, in this chapter we have some small ray diagram questions that we are going to skip completely. Why? Because in part B we are going to learn from the basics. There we are going to understand properly. For now, so what happens, to converging lens and diverging lens, all those things we are not going to do. Okay, now, so now we are going to learn complete depth knowledge about concave and convex lenses. That's it. So, and also the definitions. So from part B, we are going to learn how to draw the ray diagrams. So listen, convex lens, I told you it is converging lens. So here the important point is why it is called as converging. I told you convex lens is converging. Why it is called as converging? These kind of questions are not there in the textbook, but you should know. If you know the concept, then aram se whatever the logical question they ask, you can aram se answer it. Listen, why it is called as converging? Why it has a converging nature? See, the simple answer is the midpoint. Okay, if you take the mid portion of the convex lens, it is thicker compared to its periphery. See, this is called as periphery. Periphery means at the edge. Okay, compare this edge part and the mid part, which is thicker, the mid part. So this is why it is called as converging lens. If the mid part is thicker than the periphery, this is called as periphery. Periphery means edge. Okay, if mid part is thicker than the edge, then it has a converging nature. Compare the same thing to concave lens. See, this is the periphery, and this is a mid part. Mid part is thinner compared to the periphery. That's why it has diverging in nature. This is very much important. Understood? So why it has diverging nature? That question is not there. That concept is also not there. But if you know, aram se you can answer. So now we got to know convex lens is converging, and I have taught you why it is converging also. Now listen, there are three types of convex lens. This is biconvex. What do you call this as? Biconvex, okay, or equiconvex, or sometimes it is also called as double convex. In the same way, why it is called as biconvex? Biconvex means, convex means the spherical surface. Convex means the spherical surface, okay, it should be outward. Okay, it is outward, it is like bulging, correct? If it is bulging, okay, this is called as convex. Both the side we have bulging, right? Both the side we have bulging, correct? That is why it is called as biconvex or double convex or equiconvex. In the same way, here there is no bulging, correct? There is no bulging here. It is going inward. The spherical surface is inward, correct? It is inward. That is the nature of concave lens. It is inward, and both the side it is inward, correct? So that is why it is called as biconcave or equiconcave or double concave. Next, here see, only one bulge is there, only one spherical surface and one plane mirror. So this is called as plano-convex lens. It is called as plano-convex lens. Why it is called as plano? Plano means one of the surfaces, okay, is a plane surface. These are the two surfaces, right? When it comes to any lens, this is one surface, the other side is one surface. This is convex. Bulging is convex, correct? See, opposite of bulging, that is nothing but going inward, okay? it is concave, but here it is bulging, that is convex, and one surface is plane, so that is why it is called as plano-convex lens. Here one surface is bulging, other surface is inward. See, it is inward, correct, it is inward, so this is called as concavo-convex lens. Concavo-convex lens. See, even though we are talking about convex lens here, main types of convex lens, so it is not considered as convexo-concave lens. Okay, convexo-concave lens, it is considered as concavo-convex lens. Keep this in mind. So, which is, see, concavo, for even though it is the complete nature is convex only, okay, because it is bulging. Here on this side we are learning all the three sides. See, in all the three diagrams, this side, okay, left side is bulging, correct, bulging, so it is not called as convexo-concave lens, it is concavo-convex lens. Keep this in mind. Then if I have convex lens, what is the nature of convex lens? Converging lens, correct. But why we have to use different types? Why we have different types? Very simple answer. See, the spherical surface minimizes the angle of incidence. Okay, angle of incidence. That means whenever there is a larger angle of incidence, the image quality will be better. So if they ask, even though we have convex lens, okay, why we have plano-convex lens or concavo-convex lens, the simple answer you are going to write is to get the better quality image. So here the same answer goes for concave also. Okay, even though we have concave, okay, this is biconcave or double concave or equiconcave, anything. Why do we require plano-concave, okay, and this one convexo-concave? Why? To get the better quality image. That's it. That should be your answer. Okay, now listen. Plane convex. Okay, here one surface is plane, that's why it is called as plano-convex. Here one surface is concave, one surface is convex, that is why it is called as concavo-convex. In the same way, here also this is plano-concave lens and this is convexo-concave lens. Okay, see here, important question here only you are going to get. In concavo-convex lens and this one convexo-concave lens, in both the type of lenses we have one concave, okay, one concave, one convex, one concave. See, concave, how I am saying it is concave? Because the outer surface, okay, this side it is inward, this side it is inward, but this side, okay, it is bulged outside, so this is convex. And see, you can see the bulging, correct, bulging. Assume this is where we are going to get the rays, so this is bulging, correct, bulging compared to this one. This is inward, that is why this is concave. This is bulging, that is convex. In both the type of lenses we have one concave, one convex. Then why we have two different types? The simple answer is the mid part. See here, compare the thickness of the mid part to the periphery. Periphery means edge. So mid part is thicker, but here this is the mid part and this is the periphery. Again the edge is thicker compared to the mid part. Here we are going to get, okay, diverging image. Here we are going to get the converging image. That's it. So these are the lens and its types. Now we are going to learn some important definitions and much more about this concept. Now we will understand convex and concave lenses acts as a prism. How it can be act as a prism? Very simple. Listen. See, assume if you take the convex lens, just divide. Okay, this part almost it is like a prism, correct? This middle part also we consider as a prism, but in a rectangular shape. That's it. So the complete convex lens, we are going to assume it as lens, and we have understood how the ray diagram works in lenses, correct? The same thing we are going to apply here. Then we will get to know why it is converging and why it is diverging. Okay, so if we assume it as a prism, then we can aram say give the reason why it is converging, why the ray after hitting the this one lens it is converging, why the ray after hitting the this lens it is going diverging. Okay, so those reasons we are going to learn now. Very simple. Listen. See, we know when it comes to prism, wherever you incident the light, okay, if the light is incidented, it is always tends to move towards the base. When it comes to, assume this is the prism, assume this is the prism. If you give a light ray here, light ray here, okay, this is the base, this is the base of the prism, correct? See, this is the base of the prism. So whenever a light ray is given to a prism, okay, it moves towards the base. Keep this in mind. Whenever a light ray is given to the prism, it moves towards the base of the prism. So if you give a light ray here, see, if you give a light ray here, it moves after, okay, after the center, it moves towards, this is the base, right? It moves towards. So in the same way, if you give a light ray here, okay, it moves towards. So it is going to converge at one point. But when it comes to concave lenses, see how we are saying this is the base. Very simple. Compared to this part, this edge and this edge, which is bigger? This one is bigger, correct? See, if you take this as a prism, this is one part and this is one edge, correct? This is one top part and this is bottom. Which is bigger? The bottom part, that we considered as the base. In the same way, see here, this is bigger compared to this one. These are the two parts of, see, the center is again the rectangular glass slab, but when you take this as a prism, this, okay, is bigger compared to this part. This below part is smaller compared to this one. Which is bigger? That will act as a base. That will act as a base. So that's why whenever you incident a ray on it, it always moves towards the base. It always moves towards the base. Here also this is base compared to this one, because this part is bigger compared to this one. So whenever you give a light ray, okay, after refraction it moves towards the base, and base is here. That's why it is going away from each other. That is nothing but diverging in nature. These are the reasons, okay, why we are getting converging rays in convex lens and diverging rays in concave lens. And now the ray diagram, as I told you, the ray diagram we are not going to learn here. Okay, the simple ray diagram I am going to show why, how it is, why it is called as converging on all those things. See, assume there is a center line. It is not exactly at the center, that's okay. So there is a name for all these things, the center line, all those things that we are going to learn, okay, in the next part. That is nothing but in the same video, next slide. Okay, so if you incident a ray, see, there is no rule that it has to incident straight or parallel to this center line. It can come like this, it can hit at the center, it can, see, the ray can come like this anyway. Those things we are going to learn in part B. That is where we are going to learn the complete ray diagram. Here you need to learn only one thing, convex lens, where, okay, it will converge, okay, after refraction, okay, it will converge, it will converge. Okay, here also after refraction, so at the meeting of the center point, it will start converging. Wherever they are going to meet, this point is the intersection point, but this intersection point we cannot get it in concave lens, because see, if you incident a ray here, this is the base. See, for it, this is the base. If you take this as a prism, okay, the top half as a prism, this is a base, it moves towards the base. But when it comes to concave, okay, assume the top half is a prism, this is the base, so after refraction, okay, it moves towards the base, In the same way here also. After refraction, it moves towards the base. So all the ray diagrams, whatever you are going to do, okay, in physics, you have to use scale and pencil. Scale and pencil, and arrow marks are very, very important. Arrow marks are very, very important. So focus on the arrow marks also. Now we learn the important terms, the definitions which are very much required for this chapter as well as the next upcoming ray diagram chapter, because there we are not going to learn the definitions, we are going to use all these things. That's why these are very much important. Listen, center of curvature. Center of curvature is very simple. See, when you take any lens by convex or by concave, see from this point, okay, we can get one spherical lens. In the same way, from this point we can get one more, correct? See, actually if you take a scale or measurement, okay, all those measurement properly, you get two proper circle, okay, so the size, shape, everything will be similar, exact, two circles will be exact similar in size and shape. So here the center of the lens, if you take a spherical lens, the center of the lens of both the lens are called, okay, center of the curvature. That's it. So no, most of the time, 99% of the time, the definition will not be as based on these terms, but for safer side we need to understand. Okay, the center of a spherical lens is called as center of curvature. Next, radius of curvature. Radius of curvature. See, from the center of the spherical lens to the optic center of the lens, the distance between the center of the spherical lens and the center of the lens is called as radius of curvature. It works for both the circles. See, the same thing you can do with concave lens also. See, like this, the center is C, then from the center to the center of the lens is called radius of curvature. That's it. Next, optic center, the center of the lens, both the lens, the center of the lens are called as optic center. Then principal axis. Principal axis, very simple. See, if you extend a line, okay, if you extend a line in both the cases, an imaginary line passing through center of curvature, optic center, both the center of curvature and optic center, that is called as principal axis. See, again I am telling you, the definition based on these things are not that much important, but we need to know the terms because we are going to draw the ray diagrams in the next chapter, that is part B. So all these symbols, what are center of curvature, if you can understand using the diagram, that is also enough. Next, focus. Focus is nothing but, listen, whenever you take one example, okay, you take an example of, okay, a lens, and this is the principal axis and this is the optic center. See, this is the principal axis. Whenever a ray, okay, is incidented, whether it might be parallel to principal axis, anywhere, okay, so whenever it touches, wherever it touches at this point, okay, whenever it crosses the principal axis, well, the point where it crosses the principal axis, that is called as focus. That is called as principal focus or focus, anything is fine, okay, that is focus. So next, focal length, the distance from the focus, okay, the distance from the focus, okay, to optic center of the lens, the distance from the focus to optic center of the lens, that is considered as focal length. Focal length. Next, principal foci. In that principal foci, first principal foci, second, and focal plane first and second, all these things, okay, these things are not there in the syllabus. Even though they are in the textbook, they are not there in the syllabus, though, so don't need to worry about these things. See, if you know this much, that is enough. Okay, next, there is no need to by heart the definitions also. Just understand and write it in your own way and use the keywords like center of curvature. See, the center of a spherical lens is a keyword. Okay, the center of a spherical lens is considered as center of curvature. Radius of curvature, the distance from the center of curvature to the optic center or center of the lens is considered as radius of curvature. Then principal axis, the imaginary line passing through center of curvatures of both the spherical mirrors, okay, is called as principal axis. Then optic center, the center of the lens. Then focus, okay, here after refraction the point where the ray crosses the principal axis is called focus. Then the distance from the focus to the optic center is called focal length. If you know this much, then it is sufficient. Till now we have learned the concept. Now we are going to understand the ray diagrams. Very simple ray diagrams when it comes to convex and concave. Listen, here when it comes to, so we'll learn simultaneously so that we'll learn and we'll understand everything. If see, for a concave lens or convex lens, both, for any one of the lens, a ray can be parallel to principal axis. If I draw a line, this is parallel to principal axis, then a ray can pass through optic center or passes through optic center. Okay, then a ray can be like this. Correct. See, one, it is parallel to principal axis, one more, it is not parallel to principal axis, one passing through the optic center. So if you know all these three cases for both the lens, see, one parallel, one passing through optic center, one, see, it is not parallel to principal axis. It is not parallel to principal axis. This can be in any direction. You see, if you draw it like this, again it is not parallel to principal axis. If you draw it like this, not parallel, any direction is fine. Okay, listen, the any conditions, if you know, you can draw any diagram. Listen, in convex lens, okay, convex lens, if the ray, see, assume the ray A, B and C, A, B, C, okay, in both the lenses, the light ray A, okay, light ray A, parallel to principal axis. See, this is parallel to the principal axis. Light ray A is parallel to principal axis. So in convex lens, if it is parallel to principal axis, after refraction, it will converges. Converges means moves towards the principal axis. Keep this in mind. Next up. But when it comes to concave lens, okay, after refraction, if it is parallel to principal axis, after refraction, it will diverge. Just keep this in mind. Okay, next up. If a ray passing through optic center in both the lenses, okay, it passes without deviation. Without deviation in both the lenses, this is the case. Okay. If it is passing through optic center in both the lens, without deviation, it passes straightly. Next, if a ray, see, this ray can be like this or like this or like this, any direction. If though all the rays are in all the direction, okay, it is considered as, if a ray is not parallel to principal axis. See, this ray, see, is not parallel to principal axis, right? So after the refraction, it becomes parallel. If it is parallel, it converges. If it is not parallel, it will become parallel after refraction. Here also, if it is not parallel, after refraction, it becomes, okay, it becomes parallel to principal axis. These things you should know. Okay, so if you know this much, okay, then we can solve many theory questions. Now we learn important notes about the lenses. Very simple. Listen, if you understand all these things, based on this one only, logical questions are framed. So, and give reason type of questions as well as logical questions are framed based on these things only. So keep this in mind. Whatever we have learned, more than the terms, important definitions, we have learned so many things. That's why I will suggest not to skip these kind of chapters. Listen, note points. F1 is equal to F2. So the simple thing, a simple way to understand this one, F1, what is F1, what is F2? Listen, assume if you take, okay, if you incident a ray here, okay, focal length will be here, correct? This is the principal axis. Focus will be, see, okay, if I incident a ray here, it is going to cross here. This is the focus, correct? From the focus, okay, to optic center, it is called as f focal length. So small f represents focal length 1 and focal length 2. What is focal length 2? What if a ray is incidented here from this way? It is also possible, right? Because both the sides we have same medium. Spherical, okay, here also spherical shape, and both are convex only. Both the sides we have convex only. So we can incident ray from any side, this side or this side. It follows the same procedure. Assume initially we took it as F1 and this is F1. So now see here, this is F2, and from F2 to optic center, that is F2, small f2. So if both the mediums, okay, are same for a length, then f1 will be equal to f2. F1 is nothing but, see, f1 wherever we are, where the point where, okay, that touches the principal axis after refraction, that is f, capital F. From that point to optic center is f1, correct, focal length. This is focal length 1 and that is focal length 2. You can take anything, you can take, assume this as focal length 1 and that as focal length 2. The important thing here is the two surfaces of the lens is made up of same medium, then f1 will be equal to f2. Then real focus and virtual focus, this is very much important. Till now we did not speak about this one, correct? See, real focus is always in convex lens, and virtual focus, virtual means imaginary. I'll teach you what is imaginary there. See, real focus means what? Where we can see the focus, correct? After refraction, it is going to cross the principal axis. That point is called as focus, that we can see, okay? That is why in convex lens we can get real focus, but virtual focus means that is in concave lens. What do you mean by virtual focus? Very simple, we know, see, this is the principal axis. Now if you incident a ray here, we know concave lens has the diverging nature, correct? Diverging nature, it goes away from here, correct? So we are never going to get the focus. What do you mean by focus? After refraction, the refracted ray has to pass through the principal axis, but it is going away from the principal axis. It is never going to touch, we are never going to get the focus. So what we can do is extend this refracted ray backward. So here we are going to get the focus, right? So this is an imaginary, that is why it is called as virtual focus. So we are never going to get the real focus in concave lens. That is why we are just going to extend it backward. Wherever it is going to touch the principal axis, there we are going to consider it as focus. That is why it is called as virtual focus. These kind of questions you can expect. Then factors affecting, okay, focal length. Very important, listen. Factors affecting focal length. First, refractive index of a lens. Okay, the refractive index of a lens, how it is related to its surrounding. I'll give you an example. Refractive index of lens in air. Okay, if you refractive index of lens which is in air. Okay, assume the lens is in air. Okay, the lens, okay, is in air. Now we know the refractive index of glass is more compared to air. The refractive index of glass now, okay, that is nothing but lens, is more than the air particle. So here refractive index is greater compared to its surrounding. Now assume the refractive index value, its refractive index compared to the surroundings, it is greater, some value. Assume you take any value, assume you can take 1.3 or 1.4, you take any value. Okay, next, the same lens when it is kept in water, okay, kept in water, what happens to, okay, the refractive index of lens remains same. What happens to the refractive index of lens with its surrounding when it kept from air to water? When the lens was in air, now we take it the lens from the air and we'll keep it in, we'll dip it in water. What happens here? The refractive index of water is greater compared to air. Now, so the difference between refractive index of lens and water is less. Now. Initially, the difference between lens and air, the refractive index, the difference between refractive index of lens and air is more. Okay, it was more. Now, when you keep it in water, it becomes less. Now, that is why. So, how we can say, how it can be related to the focal length? So, here refractive index, okay, decreases, focal length increases. Focal length increases. That is why. So what kind of questions you can expect? So you assume there is a lens. When the lens is kept in water instead of air, its focal length increases. Keep this in mind. If you keep a lens, okay, in air, its focal length is less. If you keep the same lens in water, its focal length increases. Now if you take a lens, okay, which is in water now, okay, if you take this out and keep this lens in air, the focal length decreases because the refractive index, if the refractive index increases, focal length decreases. Keep this in mind. Next, thickness of the lens. Okay, thicker the lens. Okay, so here thick lens has less focal length. Thick lens has less focal length. Thinner length will have more focal length. Keep this in mind. Next, a part of lens is covered. Assume you take a lens. Okay, this is the principal axis. Assume the top part is covered. With an opaque object. So whenever a light incident on it in all the angles, okay, what happens? So these kind of questions you can expect. So if one part is covered, it may be upper part or below part, or only some part of the below part, all those, whatever the question has, the answer remains same. What is the answer? What kind of questions they're going to ask? What are the changes you can expect? See, first thing, whenever a part of a lens is covered, okay, a small part or it might be a bigger part, anything, the focal length, see, these things will never change. Focal length will never change. Then position of image, size, nature, all these things will never change. Keep this in mind. When some part of the lens is covered, position, focal length of the lens, size of the image, nature of the image, all these things will never change. Then what is the only change we can expect? The intensity of image, or you can take it as brightness of the image. Brightness of the image will reduce. Why it will reduce? Because see, most of the rays, see, some part of the incident rays are not getting refracted, so that's the reason brightness of the image will reduce. So some part of the lens is covered, focal length, position of the image, size of the image, nature of the image will remain same, okay, but only the brightness of the image will reduce. Keep this in mind. These are the note points. So if you know all these things, then the remaining part, simple, is the difference between convex and concave lens. After that, we are going to conclude this part here. See, there are many things we have skipped from this chapter. Okay, all those things are not there in the syllabus. So, and ray diagrams, when it comes to ray diagrams, some ray diagrams we are going to learn in theory solutions. Okay, the main ray diagrams we are going to start from the part B itself. That is why we are going to skip some ray diagrams also, because those ray diagrams, to draw it, you need the complete basics. The complete basics we are going to learn it in part B. That is why we are going to skip a few ray diagrams here. Now we learn our final concept in part A, that is nothing but the difference between convex lens and concave lens. Very simple. See, all these things we have already learned it. Listen, the middle part of the convex lens is thicker compared to its periphery. But when it comes to concave, the mid part is thinner compared to its periphery. That is one difference. Then here, convex lens is a converging lens. Concave lens is a diverging lens. So this is converging lens. This is diverging lens. And here the middle part is thicker than its periphery. Okay, it is exactly opposite. Okay, so middle part of the concave lens is thinner than its periphery. Then here convex lens has real focus. So it has real focus and it has virtual focus. Why it has virtual focus? That is what we have learnt in previous slide. Then, so these are the differences between convex and concave lenses. Then there is one relation. Till now they did not ask any numerical based on this formula, but okay, but for a safer side we are going to learn it. What is the relation between focal length, refractive index and radii of curvature? What is the relation between focal length, refractive index and radii of curvature of both the surfaces of the same length? So this, based on this one, till now they did not ask any numerical, but for a safer side we are going to learn. So here F represents focal length, mu represents refractive index of the lens, 1 by R1 and 1 by R2. We know when you take a lens, okay, a lens, see, because of this and this surface we have two, okay, from here to here R1, from the center to other spherical lens is R2. What are the values? Those values they will specify in the question, and which one you have to take first? Why R1, why not R2 first? Which is greater, that you have to put, okay, here, okay, which is greater, that you have to put first, then the smaller value. That's it. If you do substitute all the values, definitely you will get the proper answer. So for now we have learnt everything from the part A. So as I told you, this is not only about definitions, this is about more logical questions compared to the ray diagrams as well as the numerical part. So the give reason type of questions is going to come from this chapter only. So understand the concept properly. A few things will definitely help you in the ray diagram chapter also. Thank you.